Hi, this is Rob Yates, and this is Lesson 7 in Algebra 1, Distance Learning. If your teacher is Ms. Boatwright, Ms. Reynolds, Mr. McCrae, Mr. Still, Mr. Strickland, or Mr. Yates, you are in the right place. I remind you that you can stop this video at any time, rewind it, or fast forward it. Today, our learning target is I can factor trinomials using the box and diamond method. Factoring generic rectangles. Diagonals have the same product. Therefore, we can put the x squared term and constant into a generic rectangle, and we can multiply these coefficients and put the result in the top of the diamond. And then we put the x term coefficient in the bottom of the diamond. I remind you that the basic pattern is ax squared plus bx plus c. So, an easy way to think of this is up here at the top it's a times c, and in the bottom we put the b term. And then we solve the diamond. What two numbers added together equal b, but multiplied together equal the top? Once we find that, we find the sides of our generic rectangle and we write a product. Let's take a look at how that's done. It asks us to factor x squared plus 10x plus 24. Again, my pattern is ax squared plus bx plus c. And up on the top here, I'm going to put a times c. So I've got an x squared here and a 24 here. A is 1, and c is 24, so 1 times 24 is... You said 24, you got that right. Our b term is 10. So now what we're looking for is two numbers that multiplied together equal 24, but added together equal 10. 1 times 24 is 25. That doesn't work. 2 times 12 is 24, but it adds up to 14. 3 times 8 adds up to 11. And 4 goes into 24 6 times. 4 times 6 is 24. And 4 plus 6 is 10. So here is our magic numbers that we can fill in. 4 and 6, which we plug into our generic rectangle as 4x and 6x. Now we have to determine what the sides are. Start with an x here. X times what equals x squared? If you said x, you are correct. And now I have to ask myself, x times what equals 6x? I think you know that one. If you said 6, you are correct. And x times what equals 4x? Well, x times 4 equals 4x. Our sides are our product, so the answer is x plus 4 times x plus 6 is the product of that trinomial. All right, let's try this one. It says x squared minus 2x minus 24. Again, ax squared plus bx plus c is our standard form pattern. We can put an x squared here. We can put a negative 24 here. A times c is 1 times negative 24, which is negative 24. B is negative 2. All right. We have to remember that when we multiply a product and have a negative result, that means one of the numbers is positive and one is negative. So we have a negative and a positive. Negative 1 times 24 multiplies out to be negative 24, but it adds up to 23. It doesn't work for us. Moving on down the line, negative 2 times 12 is also negative 24, but it adds up to 10, so that does not work either. Negative 3 times 8 is negative 24, but it adds up to 5. Boo-hoo, that's not the right answer. Our next one would be negative 4 times 6, which adds up to 2, which is not quite right. I want to finish down here in the bottom, but what if we go to negative 6 and 4, that adds up to negative 2, and that is our number. So negative 6x and 4x fills out our generic rectangle. What are our sides? Well, we start with our x. X times what is x squared? I think you know that one. X times x is x squared. X times what equals 4x? Well, x times 4 equals 4x. X times what equals negative 6x? Well, x times negative 6 equals negative 6x. So our product is x minus 6 times x plus 4. All right, let's take a look at this trinomial. Let's see if you guys can pretty much do this yourself. Again, just to remind you, it's ax squared plus bx plus c. A times, so we put our x squared here in the lower left-hand corner. We put our 12 up here. 1x squared times 12. 1 times 12 is, if you said 12, you are correct. Our b term is negative 7. All right, we're looking for two numbers that multiply together equal positive 12, but added together equal negative 7. The only way we can have a positive product and a negative sum is if both terms are negative. Negative times a negative equals a positive, but of course added together they would still be negative. I'd like you to stop the video now and see if you can figure out what goes in each side of the diamond. What two numbers would that make? Stop the video now and give it a try. Well, hopefully you stopped the video and you did a little calculating on your own. I don't know where you started, but like I said before, I always start with 1. Negative 1 times negative 12 equals positive 12, but it adds up to negative 13, so that does not work. Negative 2 times negative 6 is also positive 12, but it adds up to negative 8, so that doesn't work. The next number in line would be negative 3 times negative 4. That multiplies out to positive 12, but it adds up, as I hope you've already discovered, to negative 7. So, negative 3 and negative 4 are our numbers, and we pop them into our generic rectangle and determine what our sides are. Start with an x here. X times what equals x squared? Well, x times x equals x squared. X times what equals negative 4x? If you said negative 4, you are correct. X times what equals negative 3x? If you said negative 3, you're also correct. So, our answer here is x minus 3 times x minus 4. Hopefully you got that before I gave you the answer. How about a summary? What are we calling this method we're doing? It's the what in diamond? Yes, it is the box and diamond method. It's one way to help us factor trinomials. When we factor trinomial expressions, it's like we're writing the area as a what? Well, one is the sum and the other is the product. When we get the sides, we get the product. All right, that concludes our first video lesson for the week 3, lesson 7. You can log into Khan Academy. You can log into student.desmos.com. You can try practice worksheet 7 or Google homework number 7. Thanks again. We'll see you real soon. Today's joke. Farmer asked the young man if he wanted to hear a dirty joke. The young man said yes. And the farmer said, "Pig fell in the mud." That's all for today. Thanks a lot. We'll see you next time.